the students are here. Whether shall I start?
Yes, sir.
Can you recall what was the first last topic?
Sir, method to construct transitive closure.
Transitive closure, okay.
Yes.
And there we use the concept of composition of the matrix, okay, using the Boolean product. Now today we are going to and this is, you see here, okay. Just you see, this was the problem, and this was the relations, and from this relation, it is a not transitive relations. Here we are going to find a transitive relations, okay, or the smallest transitive relations which contains R, okay, and that must be, or that relation must be the subset of all the other relations which contains R. So this is the closure, transitive closure. Now this is the main formula to find the transitive closure. Okay, this is the connectivity relations. So connectivity relation is the union of this matrix. Okay, or you can say these are the all the relations. Okay, in terms of the matrix, if you are taking the union of this, okay, or the join of this, we will get the transitive closure. This is the one way. Okay. Another way, this is the one algorithm. So another algorithm is the Warsell's algorithms. So let me see the relation first. 1, 2, 2, 1, 2, 3, 3, 4. Okay. So again, you consider the Warsell's algorithm to find the transitive closure. This is very important. Okay. So again, I am taking the example. Same example. 1, 2, 3, 4. Okay. This is the relation A, and R is the set that is the 1, 2, 2, 1, 2, 3, and 3, 4. I am taking the same problem. 1, 2, 2, 1, 2, 3, 3, 4. So 1, 2, 2, 1, 2, 3, 3, 4. Okay. And what is our transitive closure? We got it as the transitive closures. So let us try to use the Warsell's algorithm to find the same transitive closures. Okay. So what we do, so this is very important topic. First of all, step 1. Okay, step 1, set W, that means Warsell. Okay. This is equal to MR set. Okay, so W naught equals to how much? Simply MR. MR, that means it is a 1, 2, so it is a 0. First row, second column, 0, 0, 2, 1, 0, 2, 3, 0, 3, 4, it is 1, and rest are 0. 0. So this is our W naught. W naught is equal to MR, simple. Now, in step 2, we have to construct W1. So what is this W1? Step 2. So first step is simply take the 0, 1 matrix. Okay, W naught. Step 2, construct construct W1. Okay, so how to construct W1? You see, construct W1. First you take W1. You see, simply I am writing here 1, 2, 3, 4. Okay, elements, and this side also 1, 2, 3, 4, and this is for practice only. And construct the blank matrix. Blank matrix, that means we should write only the entry 1. Okay, 1 here. Second is at this place. Third is 2, 1 at this place, and fourth one is 3, 4 at this place, and leave the other place. Don't write the 0 over here. Okay. Now construct a W1 by considering first row and first column. Actually, you see, this Warsaw algorithm based on the inner points. Inner points, that means like 1, 2, 3, 4. Okay, so we are considering the nodes in between the two boundary points. Okay, and based on this we are constructing this. So construct the, that means we are considering this row and this column and this row in W1. In W2 we will considering the second column and the second row. Third, we consider third row. That means in W3 we consider third row, third column. Okay, so here with you can see that at least we need 2 more steps. Except this, we need 2 more steps to get the transitive closure. Okay, so first we take the first row and the first column in W1. Okay, and consider the blank matrix. Blank matrix, that means we are not entering the 0 anywhere. Okay, and then start with you may write the first column first. First column and first row. Okay, and here I'm considering to PI and QJ. PI and QJ. In PI, first you consider the first column. Okay, so this is the first column. What is the position where we have 1? What is the position? We have a first, second, third, fourth. So what is the position? We have 1 here. At least give me the answer. What is the position of what?
The second.
That is 2. First column, and then in the first row, this is the first column and this is the first row. In first row, what is the position of 1?
Second.
So in the first and nowhere else, and at the any other position it is 0. So leave it. We have only 2. So what we have to do? So we have to insert. Use here. We have to assign 1, and so this is the second position. This is the second position. So in you see, you can write the 2 position or 2 position. What is the meaning of this 2 position? 2 position, that means this portion, first row and the second column. 1, or you may write, leave the positions. So second row, and yes, second row and the second column, second row and the second column position. Okay, it's right, position. So here, so where we should, it is the 2. So this is the point 2. So here we assign 1. Is it clear?
Yes, sir.
Is this step is clear? And considering the rest other as a 0. Zero. Okay. Similarly, it is the 4 by 4 matrix. So we will go for this step.
Sir,
Just a minute.
Sir.
Yes. Yes.
sir, how PI is 2?
No, we are considering the two quantity pi. These are only the symbolic. Okay. So first you consider the first column. This is the for the column. Okay. So first you consider the first column. That means this column. What is the position? This is the first column. So what is the position of entering 1? First position, second position, third position, fourth position in the fourth column. Okay. It is the second position. That's why I am writing here 2. This is the only the position value. These are the positional value. Okay. Second position. And in the first row, then we consider first start with first column and then second first row, and then you consider the first row. In the first row again we have in the second position we have 1 only. So here this is the positional value is 2. So now is it clear how we get the 2 over here, pi equal to 2 and q2?
Yes, sir.
Okay.
Yes, sir.
So this is the positions. 2 is the position where we have to assign 1. Okay, in the next step. So here we assign. You see here in W0, it is the 0 matrix, 0, 1 matrix. Here we have a 0. But in the first step, we assign this by 1. Why? Because this. Okay. Why? I mean, this is the base idea. It is the position 1, 2. It is the position 1, 2. And this is the position 2, 1. Okay. So this 1, 1. 1 and 1. This is the 1, 1. So what should be the transitive entry? Transitive entry is the 2 and 2.
2, 2.
So it is the 2, 2. Is it clear? So this is the base idea.
Yes.
Similarly, now you consider the second. So what should be the second step 3? Sorry, second step. Sorry, this is the second step. It is the third step. Okay. So now construct W2 second in the third step W2 by considering second row and second column. Okay. So W2 will be how much? Again, we have the position like this. We have a 1, 2, 3, 4. Okay. And this is the 1, 2, 3, 4. Okay. So you consider here the 1, only write the, this is called the blank matrix. Okay. Blank matrix, only write the entries 1, whatever you are getting in W1. This is 0 and it is 4 again, and rest is 0. Now tell me. So now we have we are finding the W2. This is the step-by-step algorithms. Here we have a 1, 2 and 2, 1. So we have a 2, 2 over here. So we are assigning here. Now in the step 2, what do we do? In the first step, we start with first column and first row. In the second step, in the W2, we start with in W2. Okay.
Column and second row.
It is second. Second, we start with second column. Okay. And then second row. Okay. It is not any hard and fast rule that we have to first consider the column and then row. Okay. You may consider anyone, because you see here, in the W2, we assign over here 1. Okay, how we get it? It is a 1, 2 and 2, 1. That's why we have a 1. If you are considering first 2, 1 and then 1, 2, again you will get the same quantity, the 2, 2 position. Okay, but make it practiced. We first consider the second column and then second row, so that, and now construct the Pi and Qj. So now second column, this is your second column. What are the positions of entry 1 in this first column?
1,
First column is second.
And the second, good. And then consider the second row. Here it is 1, first row, first column, second column, and over third column also. Okay. So what we have to do? We have to include which pair? So
1, 1 and 2,
now we need to include the pairs. What? This is 1, 1, then 1, 2, and then 2, 3. Similarly, 2, 1, 2, 2, 2, 3. Okay, 6 1, 1, 1, 1, 2, 1, 3, and 2, 1, 2, 2, 2, 3. So we need to include the pairs this and assign 1 over these pairs. Okay, in W2. So now assign it. It is 1, 1. So it is the position 1. 1, 2. It is already assigned first row, second column. Then 1, 3. 1, 3. 2, 1 is assigned. 2, 2 is assigned. 2, 3 is already assigned. Leave it. Now it is 1, 1. Okay. Now similarly, can you find the W3?
Yes, sir.
Okay, try it. I'm simply writing here step. I'm writing only here step 3. Step 4. What is the construct? W3 by considering third row. And third column. Okay, and W2 as usual, and give it here 0. Okay, assign the 0 to all. Okay, so third row, third column.
Is it 1, 1, 1?
Hmm?
Is it 1, 1, 1 and then 1,
Let
1,
me
1?
find it. Okay, let me find. It is 1, 1. So first to write the W4. It is W2. We construct the W3 first. W3 is 1, 1, 1, 0, 1, 1, 0. Rest one is 1 over the rest of 0. So don't write. Don't write 0 over here. Okay. And we have a 1 over here and rest are 0. So this is the W3. Okay. Now whether simply construct W3. So first we consider, first we take third column. and then third row. Okay, and construct Pi Qj. Tell me, third row this, third row,
1,
and
2,
this. So Pi, I have the entry 1, 2, good, and Qi
4.
it is
4.
4. Good. So we have to include. So we have to assign 1 to the pair which pair 1 4 2 4 1 4 2 4, okay, to the to W3. Okay, now 1 4, this is first row, fourth column, and 2 4, this is 1. Okay, and rest are 0. W3. Okay, step 4. Step 5, construct W4 by considering what? Fourth row and fourth column. Sorry. So W4 only the 0 0 1, then blank matrix. So it is 1 1 1 1. Whatever we have W3, you simply write it without writing the zeros over. And this is 1, the rest of 0. Okay. Now here we start the P4, Pi and Qj. Okay. So what is the entry of the fourth array? What is the positional entry here?
So 1, 2, 3.
1 1 2 and 3. And for Qi, that means this row it is
3.
nothing.
No.
5. Okay. That means now W4 will be how much? So W4 will be so it is 5. So no entry of Qj we have here. So all the entries are 0 0 0 0 0 0. So first we consider the first row first column, second row second column, third row third column, and fourth row fourth column, and ultimately we are getting this one. So this is the final transitive closure. Okay. So therefore the transitive closure of R is, so we have only this entry, this entry, this entry, and this entry. Here we include 4. So what is the basic idea? Basic idea is to first, if these two exist, then this also exists. This two exists, then this also exists. Okay, if these two exist, then this also exists, like this. So we have a 1, then 1 2, 1 3, 1 4, 2 3, 2 4, and 3 4. Okay. So you see here, this is first row 1, second row, third row 1. So let me see the previous result. Exactly, we are getting the same result. Okay, that means it's correct. So Warcel algorithm is clear to everybody? Is it clear?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
And this is very easy to write. Okay. So now you do one thing, you try to solve a problem. Okay. I'm giving a problem. Now, if anybody has any problems who are joining the late also, I'm telling to that persons also. So if you have any problems, then let me say I will discuss it again. Any of you?
Yes, sir. Please repeat it once more. So I joined a little late. That's why.
Okay, okay, okay. So you see, Warsaw algorithm is a algorithms to find the transitive closure. Previous class also we have find the transitive closures. Transitive closures that we have, suppose the R. Okay, this is the relation R. We are going to solve the same problems here. So R is the relations, but it is not a transitive. Okay, now how can you make it the how can you construct the transitive closure of this? That means we have to construct a relation which is transitive first. Second is this must contains R also. Okay, and third is all the transitives, transitive relation which contains R. Okay, that must be the superset of that closure also. That means the S. Suppose S is the closure, transitive closure. Transitive closure is S. Okay, that means S must be transitive first. Second, this S must contains R, and if there exists any other transitive relation S dash which contains R, then this S dash must be the superset of S. That means this S must be the subset of S dash for any S dash. What is the S dash? S dash is a transitive relations containing R. That means this is the smallest. This is the smallest transitive relation. So smallest transitive relation is the transitive closure of R. Okay. So we have discussed in the previous class how to find the transitive closure using the connectivity relations. Okay. Now the second method is the Warsaw's algorithm. So in the Warsaw algorithms, we are considering the same problem. In the same problem, first, what do you do? We first set W naught. W naught, this W represents the Warsaw's. W naught as MR. MR is the 0-1 relations or 0-1 matrix of the relations. Okay. So we have, you see here 1, 2. So we assign 1 to these positional values 1, 2, 2, 1, 2, 3, and 3, 4. Okay. Next, this is the simply W naught. How can we construct the W1? In W1, we write only, so one step I'm just again I'm considering this. Okay, so we should construct the blank matrix. Blank matrix, that means we in W1, first of all, we assign only the first entries 1. Okay, in the W1, sorry. In W1, we assign only 1 to this. So 1, 1, 1, these things. Okay, is it? Next, we consider the first column and then first row. So this is the first column. Okay, and this is the first row. This is the first column. In the first column, and we just symbolize two things, Pi and Qj. So in the Pi, here I am writing the 2. What is this 2? This is the positional value where we have 1 in the first column. This is the positional value of the column where we have the assignment 1, or we have 1 entry 1 in the first column. You see, this is the second position, first, second. Okay, so in the second row we have a 1, so write it like this. Then you considering this row. In the second row we have what to do? First row, yeah, first column. In the, you see, we have 1 over in the first column, 1 is in the second position, so we have writing here. In the first row, 1 is again in the second position, first, second, so it is 2. Actually, it is in the second column, okay? But since we are considering the first row, so actually in the matrix Ij, I represent the row, J represent the column. So you see here it is the second column, this is the second row, so 2i. Okay, that means what you see in terms of the pairs, we have a 1, 2 over here, first row, second column, and here we have a 2, 1. Okay, so if 2, 1 and 1, 2 exist here, then definitely 2, 2 will also exist if it is transitive. So this position must holds in the relation. And what is the position of this? This is the second position. So here we assign 1 over here. Okay. So in the second step, sorry. In the second step, what we will do? We simply, this is the position 2, 2. So you see here, we have to assign 1 in 2, 2 position. So this is the 2, 2 position. We assign 1 over here and then assign 0 to the rest.
So,
Yes. Yes.
also please repeat this step once more.
You see here, okay. And same is applicable to all the steps. You see, this is W0. Is it clear? W0 is clear?
Yes, sir.
Then come
Yes,
to
sir.
W1. In W1, we should write only the entries 1 and left the other positions. Okay, entry 1. Okay. Now, first we consider the first column and then first row. Here I am writing. Start with first column and then first row. In the first column, what is the position where we have 1? What is the position? First, second,
So
third,
2,
fourth.
1.
2. So we assign 2 here. Simply write, symbolize this one, Pi and Qj. So it is the 2 over here, first column, and then first row. Go to the first row. In the first row, what is the position where we have 1?
2.
Okay, 2. So 2, 2. So now we consider the pair 2, 2. We consider the pair 2, 2. What is the position of 2, 2? This is the position of 2, 2. First
Yes,
row,
sir.
second row, second column. So here we assign 1. Here we assign 1 and leave the other rest. Is it? So make it 0.
Yes.
Now is it clear?
Yes, sir.
Okay. 0, 0. Leave it. Now come to the second, next step. That means step 3. In the step 3, only write the entries 1. Okay? In W1. So W1 we have these 5 entries. Okay? Now we consider same. Now we consider the second column and then second column and then second row. Sorry, this is the first row. This is the second row. Okay. So what are the position where we have the entry 1 in the second column? This is the, we are finding the W2. Okay. So in W2 represent the second column, second row. So in the second row, what are the positions where we have a 1? What are the positions? First, second, third, fourth.
1, 2, 3.
No. Only 1 and 2 in this column. 3, 4 is 0. You see, 3, 4 is 0. In this first column, we have a.
Sir,
This
I
is
was
the
actually
first
saying about
1, 2. And in the second row, we have the position 1, 2, and 3. So here we assigned Pi. So you see Pi. So in Pi, we assign or we are considering the positions where we have a 1. So it is in the first position, it is in the second position. So 1 and 2. And in the second column, as in the second row, we have the position 1, 2, and 3. So we have a 1, 2, and 3. Is it clear?
Yes, sir.
So now you construct the pair. Pair is 1, 1, 1, 2, and 1, 3. Odd pair, that means ordered pair. Okay. So you see here. So 1, 1, 1, 2, 1, 3. 2, 2, 2, 2, 3. So we have now we have a 6 ordered pair. Okay, where we have to assign 1. Okay, so what we do in this step 2, 1, 1 position. So here I am right assign 1. Then 1, 2 position. We have already 1 over here. 1, 3 position assign 1. Okay, so now 2, 1 position. We have already here 2, 2 and 2, 3. We have already positions 2, 2, 2, 3. So this is the final W2 matrix. Is it clear?
Yes, sir.
Okay. If anybody has doubt, okay, again tell me. If anybody has any doubt, then tell me, I will repeat it again from the beginning. No, leave it. In W3, so here we have a first 3 rows and column and then this one. So next you construct the W3 by considering only these entries. Okay. And now here we consider the third row and third row. This is the W3, third row and the third column. So in third row, what are the position where we have entry 1? It is the first and the second position in the third column. And QJ, it is in the fourth column. If okay, so it is the position first, second, third, fourth. In this row, we have the fourth position where we have a 1. So right here 4. So now construct the pair 1, 4, 2, 4. 1, 4, 2, 4. So next step, what you do 1, 4. That means here I am writing 1, 4, and this is 2, 4. And again rest are 0. Okay. So leave it.
Yes.
Now similarly construct the W4. In the W4, you see here we have a W3 like this. So again construct the blank matrix this. Okay. Now come to the fourth row, fourth column, fourth row and fourth column and the fourth row. So what is the entry in the, what is the positional entry of this fourth column? It is 1, 2 and 3, first position, second position, third position, and we haven't any 1 in the fourth row. Okay, so it is 5. I'm writing 5. That means no entries are there. So we haven't any ordered pairs in this 4. So now, since we haven't any, so nowhere we have to assign 1, and we are simply writing 0, 0, 0, 0 and 0. So this is your final. If you have a 4 by 4, you will come up to W4. If it is the 5 by 5, you will come up to W5 and these things. Is it? So
Yes,
this is your transitive closure, and you can match it with this one also. We have solved the same problem. This is the same problems by another method to solve. Okay.
Yes, sir.
Okay. Now, just simply you consider the problem. I am giving a problem from the book of Kenneth Rosen. You can see the question number 25 and 26 of page number 498. question is, suppose we have a set A equals to A, B, C, D, E. Okay, A, B, C, D, E, and suppose our relation R is given by, suppose here it is BC, BC, BE, CE, DA, EC. Okay, this is there. Construct first one, reflexive closure. Second is symmetric closure, and third is transitive closure. Transitive. So Warsell's algorithm is more easy than the connectivity relations, method of the connectivity relation. So you should find this. So if you are finding the reflexive closure, so what should be that? Just simply include A, B, B, C, C, D, D, and E, E. Okay. And what is the symmetric closure? If BC is here, then CB should be here. Is CB here? No. Then include CB here. BE, then EB should be here. Yes, it is here. Leave it. Okay. And CE, so EC is here. Leave it. DA, then AD should be here. So you have to include CV and AD. CV and AD to construct the transitive closure, symmetric closure. Transitive closure, here you should use the Warsell's algorithm. Warsell's algorithm. Is it clear?
Yes,
Yes.
sir.
So try to solve it. So you may try question number 25, 26, and very important is 29 question number. Okay. So next class we will start some function hash diagrams, everything is there. Okay. So now tell me, anybody has any queries about this topic, Warsell algorithm? This is a very important algorithm, and questions definitely comes from here. And on Wednesday you have the test. Okay, you have the first quiz, and tell me the date of the, in coming couple of days you just tell me the date of second quiz also. Okay. Any doubt? Any doubt related to this topic?
No, sir.
Okay, good. If anybody has any problem, then frankly discuss this one. Otherwise, you can't understand. And this is the base of the computer science. This is the actually discrete mathematics. From here, you gain the mathematics of computer. Yes.
So while
Yes.
solving the problem of Warsell's
Yes.
algorithm, do we have to show the steps also, or we can write directly?
You can write directly, no problems. Or at least write the whatever I am writing here. You are
Okay.
considering the second row and second column, or the third row and third column like this. In the
Yes.
second row, we consider the third row and third column. Okay, like this only. Okay.
Yes.
If you are simply writing the steps, no problem, you will get the marks. Any other queries?
No, sir.
Okay, today I conclude the class.
Thank you, sir.